Welcome to the Insightful Professor. Today's topic is conditional logic, where we introduce the basics of formulating conditional expressions within a program using Boolean expressions. Now, when we talk about how programs execute, the instructions are going to execute in a particular manner, which we call the flow of control. The default behavior tends to be execute one instruction, then the instruction that is physically coded after that in kind of a sequence or linear fashion will then execute, and then the next sequential instruction and so forth. Looking at our code here, we mentioned that we start off by executing the first instruction, declaring the scanner object, the second instruction, invoking the print line method, declaring a variable, and then continuing on invoking the nextInt method for the in object. So again, in a sequential fashion, we execute one instruction, then an instruction that sequentially follows that is executed. In this example, we're using Java, and code is executed in the main method, and that's what we're illustrating here with this block of code. Now, when we execute by default, we are doing it in a sequential fashion. So this is sometimes referred to as a simple sequence flow of control. And again, that's effectively what we've just presented. An alternative to this is to use something called a selection. With a selection, we introduce some kind of a condition that will be evaluated, and in response to the evaluation, that condition is going to be either true or false. And if it's true, we may go down one path and execute some instructions. If it's false, we will go down another path and execute alternative instructions. In addition, we have another operation or control structure called iteration. We'll talk about this in a later video where we talk about loop processing. Basically, you're doing a test, and if the test is true, you perform an operation and then do the test again. And as long as that test remains true, you continue to perform the operation. But our emphasis in this particular video is going to be transitioning from a simple sequence to this notion of a selection. So what we'll do is we will write conditional statements. Conditional statements are also sometimes called selection statements because they're selecting a particular path of execution. The conditional statements available in Java are the if statement, where we have if then, an alternative form or expanded form of the if statement called if then else, and then finally a switch statement. The condition that is evaluated is referred to as a Boolean expression, or sometimes just called a condition or a conditional expression. The result of evaluating such an expression is a value that is true or false, and within a conditional statement, we say, should the value become true, take this path of execution. If the value is false, take this alternative path. So we're going to test the expression within the conditional statement. The Boolean expression can be formulated by using relational operators. The standard relational operators available in Java are listed here. We have less than or equal to, greater than or equal to, equal, and notice how equal is coded, two equal signs, and then not equal. Exclamation mark equal is how we express not equal. Examples are shown here, where we have the variable a is equal to the variable b. And we're coding this expression. That expression is effectively a statement we're making, and that statement is either going to be true or false, depending upon the actual values that are part of or stored by A and B at the time this expression is evaluated. Another example here is C. The contents of variable C is greater than or equal to 0. So what you're seeing is we can compare the values of two variables. We can compare the value of a variable against the value of a literal. Finally, we want to emphasize what we were talking about up here, that the equal operator is two consecutive equal signs. Remember that a single equal sign in Java is actually the assignment operator, where we might read this as A equal 0 In reality, this is an assignment statement, which should be read as the variable a is assigned the value of 0. This is not a comparison of the value of variable a to 0. To do that, we use the two consecutive equal signs. This is a way that we alter the content of the memory associated with variable a, assign it a new value. The percent sign is actually the not operator in Java, and it's used to kind of negate the value of a Boolean expression. So the Boolean expressions, we were giving you an idea of how these might be formulated using the relational operators. If we were to precede the Boolean expression with this not operator, with the exclamation mark, we're effectively toggling the value. Remember, there are two possible values for a Boolean expression. The expression could evaluate to true or could evaluate to false. When we negate it, we're effectively taking the opposite value. So the negated expression becomes true if the actual Boolean expression to which we applied the not operator is currently false. Thus, not false is true. And likewise, not true is false. Simply negating the value gives us the other value because it's simply two-value logic, kind of a toggle. It's sometimes confusing, and you're probably confused by what I just said here. It's sometimes confusing when negation is used in an expression. So be aware that we have options very often of avoiding that. And probably it's a good idea to avoid using negation. So here's how we can avoid the use of negation within a program. If we have an expression such as a and then some kind of a relational operator b, a greater than b, a equal b, and so forth, and we negate it, that negated expression effectively toggles the operator in some way. If the operator within this expression here, and let me bring that up by making it a little bit clearer. We're saying if this operator here within this negated expression happens to be less than, then we can remove this negation operator, but our expression is such that this becomes the operator that we're using. So not a less than b becomes a greater than equal to b. And this little table gives you a quick guide as to how this would be accomplished for the other operators. It's a little tricky, so let me give you an example. Consider we've got an expression, number is greater than or equal to 0, and this is negated. So we're saying not number greater than or equal to 0. According to what we see in the table, we find the greater than or equal, that's this guy here, and what we do is we can remove the not operator, and the expression becomes number less than 0. That's what we'll put in. So we're saying not number greater than or equal to 0 could be rewritten without the use of the negation operator to number is less than 0. Let's walk through a little example to give you more detail. Let's suppose the value of the variable number happens to be 0. The expression number greater than or equal to 0 would evaluate to true. If the value was 4, number greater than or equal to 0 would also be true. And likewise for 99, it would be true. But notice for -3, the value of number greater than or equal to 0, that's false. Now, let's use the negation operator. Same expression, except we precede it with the not operator. So notice we're saying we simply toggle the values. True becomes false, false becomes true. That's a kind of a way to think about it here. And again, let's look at another way. We're saying instead of the not operator, let's rewrite this. And again, based upon what we saw in the table, the greater than equal to becomes less than once we remove the not. And we're saying that this should be an equivalent expression. So let's look at this. It says number less than 0. Is 0 less than 0? It's not, so that's false. 4 less than 0. That's false. 99 less than 0. That's false. And -3 less than 0. That's true. So take a moment and look at this carefully and see if it makes sense to you. And I encourage you to try out some of the other, say, variations or possibilities within a table to confirm your understanding. So using the sample values that we've just seen, we do indeed see that the expression not number greater than or equal to 0 can indeed be rewritten without negation as number less than 0. Now, in this video, we did a very quick overview of conditional logic, specifically Boolean expressions. We introduced some important concepts that are going to relate to the execution of the instructions within a program. We talked about flow of control structures. We reviewed the concept of a simple sequence, and we discussed where the selection will come into play, but in order to do that, we need to understand a conditional expression. Likewise, we hinted that there's another control structure called iteration for loop processing, but that also will involve the use of some kind of a conditional expression or Boolean expression. So we're getting you ready to introduce these alternative flow of control structures, and we'll do that in a subsequent video. So we talked about the concept of a conditional statement where we are effectively evaluating some kind of a Boolean expression. Now remember, a Boolean expression results in a true or a false value, and these can be used within the conditional statement. The relational operators were introduced, and we remind you once more that equal is the actual equal operator to compare one value to see if it's equal or the same as another value. And the single instance of the equal sign is the assignment operator. Okay, hopefully you found this video to be informative and useful. And if you have any comments, offer those in the comments section. Consider, if you enjoyed it, found it useful, giving a thumbs up, and perhaps subscribing to the channel to be notified of posting of future videos. Again, we will be following this up with a few more videos related to conditional logic. We've hinted at what some of those are right here. And once again, thanks for watching.